a lot of additional light on these ideas worth sharing. When I was 7 years old, I sat in front of our black and white TV way up in our lake house in Canada, and I watched Neil Armstrong step onto the moon. How many of you did that? It was incredible. I went out at night. I was trying to see if I could see them on the moon. Well, this was our vision, our bright future in space in 1952, before any spacecraft ever flew. This is Wernher von Braun's vision of the future in space with beautiful ideas like a rotating space colony for 200 people. And gosh darn it, they even were thinking of how to go to Mars with all these tanker ships and whatnot. And amazing, amazing, amazing future. And 1968, Stanley Kubrick made a film called 2001, The Space Odyssey, and he depicted this space station for 200 people and a Hilton hotel and everything. 2011, this is what we built. This is what humanity built for 6 people. Well, good news is there's something now called new space. And you've got incredible entrepreneurs making inflatable habitats. You've got entrepreneurs making brand new low-cost rockets. And these guys are talking about how can we go to Mars? Well, why am I up here talking to you about this kind of odd kid that I am still? Well, since Neil Armstrong, since I saw him, I got totally enamored of space. And this is me doing a talk in my town in Canada, just out of high school. And this is me drawing asteroid miners and doing a whole series of articles in the local paper on what would be. I even designed asteroid capture missions, and I sent them to NASA. And I got these letters back like, yes, indeed. But don't laugh. 20 years later, this is me. I at NASA. Thank you. I did 25 projects with our team on simulating all their missions, everything, rovers, space stations, you name it, simulated the whole thing. And in 2007, they came to me and said, Bruce, we need your help to figure out how to put people on an asteroid. He said, you're kidding. He said, no, you've simulated everything. Go for it. So I drew this, and it became this. A whole new direction for NASA that was controversial at the time, but it became their direction. This is my design. So, but this comes back to the question of why haven't we done more, right? Why haven't we done more? Well, it costs thousands of dollars a kilogram or pound or whatever you want to lift water and fuel and food and hamburgers and whatever into space. It's just expensive. And, that space station that Stanley Kubrick showed, that would be 1,000 launches. Not practical. So I was out thinking one night, and it was a summer meteor shower, and I saw this meteors coming in, and I thought, wait a minute, we're passing through the tail of a comet, which is made of mostly water, and the Earth is getting showered with this remnants of this tail, and I thought, what if a comet, instead of just the meteors, what if a comet got captured in the Earth-Moon system, and it was just going around and around? Well, that would be so valuable. There'd be thousands of tons of water and fuel and stuff. So I went to work on it. So I designed this spacecraft. It would be a huge fabric structure, go around this icy object and capture all its juices. And it wasn't really practicable until I met this man, the august meteor astronomer Peter Janiskins, who knows about meteors. And initially he said, your idea is not going to work. And then we went out for a bowl of clam chowder, and by the end of that he said, here's how it'll work. We'll introduce gas into the enclosure and it'll control the asteroid. And he rang his friend Julian Knott up, who's a preeminent balloon designer, and he and I worked for a month to design the balloon structure. And this is how it works, folks. Shepard, the wildest spacecraft in the next 50 years. Coming up to the asteroid, robotic spacecraft, we scan it with our LiDAR. We don't want to get tangled up with this thing. It might be 25 feet long and 1,000 tons, much bigger than us. And there's our balloon structure closing down around it. That's my seal design, made of curtain rods. You go in, look in the inside. We're introducing xenon gas, 1/10 of an atmosphere. Why? Because the friction in the gas is going to allow us to control this thing and stop the tumbling. 1,000-ton thing in 3 weeks. We have stopped it. It is our space potato. It is now ready for roasting. So now we push it with waves of gas, very, very gently, and push it and fire out back, and we can move these things all over the solar system. Why are we doing this? Well, different kinds of things are out there. We're made out of the building blocks of these things. Here's a comet visited by the Europeans, made mostly of water, methane, those kinds of things. Here's a nickel iron object that fell on Oregon. Just solid nickel iron, incredible stuff. So what do? We go and use Shepard to encapsulate these objects. This one might be mostly ice. So we're going to heat the interior and fractionate the water off and just boil it off and put it in our tanks. And we can make it into rocket fuel and air to breathe and consumable water and then move it to where we need it. Here's our nickel iron asteroid. We can put carbon monoxide gas there and drive it through this asteroid, and it will electroform on a form here, and we can make big parts. This is a big 3D printer in space. Crazy stuff. This is the most crazy and beautiful of all. This is a biosphere. Instead of completely melting down our dirty snowball, we can turn it into a liquid phase, into this globule. And we can introduce plants, we can introduce fishes, we can create a biosphere in space, and we can use it to live in space. So here's how it would work. Here's how this radical, total game changer would work. We want to go to Mars. People are talking about, let's go to Mars, but they're talking about one-way trips. I don't want to go one-way trip anywhere. So we take Shepard and we go out to the outer solar system to what's called the snow line, where you get icy objects, and we grab one. And as we get it in our enclosure, we move it to the orbit of Mars, and we process all its materials. It might be thousands of tons. And then the human crew can leave from Earth, and they arrive at Mars, and guess what? They have a tanker block filled, ready to go, just like your CO2 canister you take to the hardware store. So it goes onto the ship. Now they have return fuel. They can go home, which is a good thing. And they also have fuel to take their lander all over Mars. This is a totally new way to go to Mars. It works. And remember that wonderful big rotating space station? We can build one. This is just like Wernher von Braun's vision, except now we're making the parts in space with a Shepard miner. And we're feeding the crew in space. They get their hamburgers. A sustainable way to stay in space. Hello. So I would say to my young self back in the high school days, and for young people in the audience, you can have a dream and just keep working on it, and it can come true. So here's me back when I was 19. Here's Wernher von Braun's little vision. Notice the tankers? He's asking, can we get to Mars? I would say to you, we can go to Mars. So, a special little announcement. The three co-inventors, the radical collaborators on this idea, we applied for NASA funding last year. We kind of thought we would not get approved, and they didn't pick us. They had good written all over the proposal. I think it kind of stumped them in a way, because it's so new. It's a crazy idea. So we met and we decided, let's just open source this thing. We'll give this away to humanity. Then we can license or patent this now that it's being presented here on this stage. We give it away to the entrepreneurs, anybody who wants it. And we can take the pressure off Earth, and we can move our civilization into the solar system. So that's my radical idea worth sharing. Thank you. Now that you've heard the TEDx talk about Shepard and how it could be a game changer for the future of humanity in space, let's keep going on an extended excerpt from my appearance on the Midwest Real podcast, recorded just a week before the Santa Cruz TEDx. This will provide valuable additional illumination, as you might have noticed that during my TEDx talk I was referring to slides which you obviously couldn't see. The following extended discussion should give you a much clearer picture of the vision for Shepard.
I think we should go back to outer space, because we have gone everywhere but outer space, and that is another realm that you are involved in. You've worked on a bunch of contracting projects for NASA. I know you're doing something with SETI. You mentioned you have a spacecraft that's going to actually be built. What's the story there?
Well, it's this bizarre contraption. One night, 10 years ago, I was standing down by Hangar 1, which is this incredible building down at Moffett Field in Silicon Valley. It was one of the greatest buildings in the world in 1932. It was for airships. And it was like the highest tech thing on the West Coast. And it attracted all these aircraft companies that became the basis for Silicon Valley. So a really cool building. It's now got all its skin taken off, so it's this sort of skeleton. I think Google wants to buy it or something, to put all their private jets in there. But I was standing there with my friend Brad, and he's like a lunar mining engineer dude. He's from Colorado, so he thinks we're going to mine the moon and get all this ore and helium-3 and water and stuff like that. And I kept being bothered by that because my family is in mining. My brother drove a haul truck, carries 300 tons of ore. He would take me into the mine, and mines were all around our town. I mean, our whole town would shake every time they blasted a bench. And my brother would look at all my simulations for NASA about lunar excavators, and he would just laugh and laugh and laugh. And he says, who's going to be around with a mountain of spare parts to fix that thing when it breaks? Because it's going to break right away. Robotic miners, you've got to be kidding. Especially in that cold, teeth will shatter. We have to shut down our mine when it's 5 below. In Canada, they have to, because the metal parts start shattering. It's like, you're going to operate at cryogenic temperatures, and he just laugh and laugh and laugh. And but I would go back to these space conferences where, again, people that have no experience are just talking about lunar bases, and I said, this is just nonsense. All this stuff is nonsense. And I said, there has to be a better way. And so Brad and I are standing there, and I'm having this argument with Brad again about, if you're going to hard rock mine in space, you got to move all of human civilization to space to do it. Because you need a guy with pizzas and a mechanic shop and like plenty of beers and everything to maintain this equipment. This is how it's done. And he would not be able to argue against me, but then the impasse was broken by the fact that I looked up at the dusk falling over Hangar 1, and there was a flashing light started. And this is the aircraft light, because the building's tall enough to be a problem for aircraft, especially at the air station. And I said, Brad, what if that light wasn't a light on Hangar 1? It was a comet that got caught in the Earth-Moon system. It just got trapped, and its tail's going, it's burning off all of its stuff, and it's like 3,000 tons or whatever. And it's just going to orbit until it burns up into a nucleus, and the nucleus is left. And he said, well, that would be the most valuable real estate in the solar system. Every spacefaring nation would be trying to claim it. And I said, well, why? And he said, because it would have thousands of tons of water that you can break up into hydrogen and oxygen for rocket fuel, carbon dioxide, methane, you name it. And this building blocks of life. It's full of amino acids. It's full of nucleobases and blah, blah, blah. Even basic materials for agriculture. And then I said, well, why don't we learn how to go and get those things? Wouldn't any spacefaring civilization have a ring of that stuff that was falling down when life was starting? They would just bring all that shit and put it into orbit and just basically use it to build a spacefaring civilization. It's like no-brainer. So I brought this up at a NASA meeting, and some guy said this is a no-brainer. So then I started working on it and came up with this idea of a balloon. The spacecraft would come up to an icy asteroid and extend this balloon structure completely containing the asteroid, and then heat the interior. And as the ice starts to melt and little jets come off, not too fast because it'll tear you apart, you start to take all those jets, and instead of them just being random jets, you fractionate it and put it into your tanks, bust it up, and use it as propulsion fuel for very low power rockets. And then you can move the asteroid using its own juices.
Wow. Yeah.
Using this shit that came up.
Holy shit, yeah. Yeah, and you sent me graphics of this, and it really looks plausible. Like you said, these are just flying gigantic multi-ton chunks of things that we consider to be valuable here on this planet. It's the idea of commercializing space almost seems kind of perverted in a way, but it's also kind of beautiful because eventually it will lead to the ultimate conclusion of being able to explore space, which is something that we have not been able to do because it's too expensive. There's no payoff. Nobody wants to, increase taxes so we can go to Mars or something. But now this is an endeavor that will essentially fund itself if you can make it inherently valuable.
Yeah, and here's the cool thing. Back in the 50s, when Wernher von Braun did those articles, and then Stanley Kubrick showed those big rotating space station, blah, 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 that was supposed to be around by 2001 and house 200 people. And we launched something in 2011 that can hold 6 people. The reason is because we're not constructing in space, right? It's obvious. A 100,000 ton rotating space colony is not going to be launched by 10,000 rocket launches. It's ludicrous. So what happened with the invention of this Shepard spacecraft a year ago, we call it Shepard because it kind of gently moves things, because it turns out that the object inside the balloon, you never have to touch it. You can use gases to change its spin, to stop it spinning, and then waves of gas pushed onto it like a sailing ship, very, very light wind, and you can start changing the orbit and moving it that way. And that's the true genius of the invention. But it turns out that the gases you put in matter. So if it's a big nickel and iron asteroid and you put carbon monoxide gas into it, guess what happens? A guy in the 19th century invented this process called the Mond process. The gas will pull nickel out of that asteroid and pull it along an electric field to deposit it on a form. And you can make freaking huge multi-ton parts out of metals and alloys out of asteroids without ever touching them. Not doing hard rock mining, but using gas mining. It's a gigantic 3D printer in space. So that was invention number 2. Invention number 3 was if you come up to your asteroid that's mostly ice and you start heating the interior, instead of drawing all the stuff off as vapor, just let it melt into a huge globe of water. And in the center will be the old nucleus. And then you inject biology. You inject algae and plants and, whatever you want to put in there. And you put fish in there in an ocean. 200 feet across or 50 feet across or whatever it is, they're going to be protected from radiation. They're going to just be swimming away. You're going to have lights in the interior, solar panels on the exterior, and you just create a biosphere, just like one of those glass globes that people buy that have fish in it and plants and they're self-sustaining. You just created a living biosphere, a copy of the Earth. You farm it and fish it in order to sustain life in space. And then it just keeps going and going and going, because you can then move these things by their hundreds throughout the solar system. You can have a futures market and a commodities market on delivery of X amount of stuff for hamburgers or salmon burgers at Mars and 1,000 tons of water to low Earth orbit, so we can put it in our inflatable habitat to surround the crew with 1.5 meters of water so they're protected from radiation so they can actually go to Mars safely. No one solved that freaking problem until we came up with that in January. It's like, it solves every problem. And when yeah, go ahead.
Did you hear now apparently there's some engine that has been conceived of that would supposedly enable a manned trip to Mars?
That's the Vasimir engine, yeah.
Get there within like a little over a month or something?
And those are all wonderful and exotic technologies, but frankly, I'm not a believer, of course, in energy from the zero energy state or whatever they call it, and all these exotic things. Some of them are purely woo-woo, and some of them are just technologies that show promise but have never been used. If we can simply get the building blocks of your basic stuff, water, carbon dioxide, methane, some hard carbons, you name it, these are bulk materials. You're not refining them really much, except you're separating them. You can do old-fashioned, high propulsion, high energy trajectories, because you're bringing this icy object to, say, low Earth orbit, and it takes you 4 years. But on the way, you've used your solar electric blankets to do electrolysis, and you separate into oxygen and hydrogen. You have a really high-performance fuel for rockets. So when you then take that tanker block section, you release the object, the asteroid, let it go, because most of the materials, the volatiles, are now gone. And you don't want to bring that to low Earth orbit because it's just junk. Just let it go. Then the ship can turn itself around, fire a rocket engine using the fuel that it's processed, get to Earth fairly quickly, and then a ship can actually attach that section onto itself. Like when you go to the hardware store and you take your empty CO2 canisters and they give you full ones, for your soda stream.
Yeah.
And there's a block, and it was paid for by X amount, and that block is sufficient to take a crew to Mars, or maybe 2 blocks are sufficient to take a crew to Mars. When they get to Mars, there's 3 blocks in orbit that are full, so they can come back. It's not a suicide mission. They lose their empty blocks, put the full ones on, fuel their lander to go multiple points on Mars, so they can explore all of Mars. And those empty blocks are attached to Shepard capture mechanisms. And with the fuel they have left, they go and capture more icy objects. So it's totally reusable because, there's a contract for them and blah, blah, blah. So it's such a better way to go to Mars than anyone's ever come up with. Well, this is it.
Sure.
This is totally it. And it's funny, like a month ago, I designed the Mars ship. And I said, wait a minute. You can't even do things like, why bother having a fuel line go and refuel the tanks? That's high risk. What if something didn't work? Just have a complete tank block already there. Take your crane, take the old one off and put it on. Do everything the simplest, easiest, lowest risk way you possibly can. And you make a mission that's viable.
So just to reiterate, this craft that you conceived of to capture asteroids, bring them into Earth's orbit, and mine them, this is actually going to happen?
Well, what we're doing is we had put this in a big proposal for NASA a year ago for about $475,000 to do some prototyping. We had a shop lined up to do the computational fluid dynamics, to build a mock-up 6 feet across. We can hang in a vacuum chamber, really do the work, right? On building a small-scale prototype, figuring out how to seal it, and et cetera, et cetera. And, of course, we didn't get selected. We got very good marks on the proposal. I think it was too out there for them. We stumped the rocket scientists, with this thing. So people were depressed on the team, and I said, you know what, this is just phase 2. Phase 2 is different than it was 10 years ago. We have new space. We have Elon Musk with SpaceX. Yeah. We've got Robert Bigelow with his incredible work. We've got Jeff Bezos. We've got all these people. And they
Virgin too, yeah. Doesn't Virgin have a space arm as well?
Well, that's suborbital sort of flights, though. That's not real space.
Okay.
But he's not trying to solve all these hard problems. But I said, we have these people. So we had a meeting in San Jose with the team, and including a well-known space lawyer who gave us the idea for gas mining, which is really interesting. And I said, do I have your permission to go public with this and open source this idea? Because I've got all my media people lined up. I've got several people in the media who will do a fantastic job. One guy who's going to fund a documentary about it and start filming in September, which he's done.
Very cool.
So usually what I do, when I have these visionary ideas, the whole back part of it is not only visualizing it with drawings and vision, but then it's setting up the machinery to shove it out to humanity in just the right way. And so that's what's going to happen. The paper was published last month on the spacecraft in the technical literature. And then a week from today, it will be out in the public through TEDx. And then the TEDx talk will go out in May online. Then the stories will start coming out in the media. Full-on documentaries and a scattering of other stories, which we're hoping to kind of cast as the Collier's von Braun vision for the 21st century. So we completely give it away. It's open source. No one can patent this thing. Nobody can license this thing. And then if Elon wants our team to come down to SpaceX and do a presentation,